Sign convention for spherical lenses. All the distances measured from the optical center of the lens. The distances measured in the same direction as that of the incident light are taken as positive. The distances measured against the direction of the incident light are taken as negative. The distances measured upward and perpendicular to the principal axis are taken as positive. The distances measured downward and perpendicular to the principal axis are taken as negative. This is called the new Cartesian sign convention for lenses. The object is always placed on the left side of the lens. The focal length of a convex lens is considered positive and it is written with a plus sign. The focal length of a concave lens is considered negative and written with a minus sign. Lens formula. Lens formula is the formula which gives the relationship between image distance small v, object distance small u, and focal length small f of a lens. The lens formula can be written as 1 upon small v minus 1 upon small u is equal to 1 upon small f, where small v is image distance, small u is object distance, and small f is focal length. Magnification produced by lenses. The linear magnification is the ratio of the height of the image to the height of the object, which can be written as magnification is equal to height of image upon height of object. So small m is equal to h2 upon h1, where small m is magnification, h2 is height of image, h1 is height of object, h is also written as small. The linear magnification produced by a lens is equal to the ratio of image distance to the object distance. Thus, magnification is equal to image distance upon object distance. Small m is equal to small v upon small u, where small m is magnification, small v is image distance, small u is object distance. Rules for obtaining images formed by concave lenses. Rule 1. A ray of light which is parallel to the principal axis of a concave lens appears to be coming from its focus after refracting through the lens. Rule 2. A ray of light passing through the optical center of a concave lens goes straight after passing through the lens. Rule 3. A ray of light going forward towards the focus of the concave lens becomes parallel to its principal axis after refraction through the lens. No matter where the object is placed in front of a concave lens, the concave lens always forms a virtual and erect image, and the image is always diminished in size. The positions of the object can be anywhere between the optical center and infinity or at infinity. Position 1. Position of object anywhere between optical center and infinity in case of a concave concave lens. When an object is placed anywhere between the optical center C and the infinity in front of a concave lens, the image formed is between optical center and focus. It is virtual and erect, and it is smaller than the object. Position number 2 of the object. When the object is at infinity from a concave lens, the image formed is at focus F, virtual and erect, and the image is highly diminished in size, or it is smaller than the object. Uses of concave lenses. Concave lenses are used in spectacles to correct the defect of vision. Concave lens is used as eye lens in telescope. Concave lens is also used to make high quality lens system for optical instruments, and it is also used as spy hole indoors. Lens formula and magnification formula for a concave lens. The lens formula for a concave lens is the same as that of a convex lens, which is 1 upon small v minus 1 upon small u is equal to 1 upon small f. The magnification formulae for a concave lens are also just the same as that for convex lens, which is small m is equal to h2 upon h1 and small m is equal to small v upon small u. Power of a lens. The power of a lens is a measure of the degree of convergence or divergence of light rays falling on it. The power of a lens depends on focal length. The power of lens is defined as the reciprocal of its focal length in meters. So, we can write it as a formula: power of lens is equal to 1 upon focal length of the lens in meters. A lens of short focal length has more power, whereas a lens of long focal length has less power. The unit of power of a lens is diopter, and it is denoted by letter capital D. 1 diopter is power of a lens whose focal length is 1 meter. The power of a convex lens is positive, and it is written with a plus sign. The power of a concave lens is negative, and it is written with a minus sign. In order to calculate power of a lens, we need its focal length in meters. In many problems, the focal length of a lens is given in centimeters. So to calculate the power of such a lens, we should first convert the focal length of the lens into meters by dividing the given centimeter value by 100. Power of a combination of lenses. If a number of lenses are placed in close contact, then the power of the combination of lenses is equal to the algebraic sum of the power of individual lenses. Thus, capital P is equal to P1 plus P2, where capital P is the power of the combination of lenses. P1 plus P2 is the power of the individual lenses.